Hello everyone, I'm Hiroshi from Ninja Labo. Today I'm going to talk about hardware-agnostic compression of hyperspectral image deep learning models for efficient satellite deployment. Ninja Labo is a Finnish startup specialized in compressing DNN to run over diverse hardware environments. As you know, big AI models like LLM are becoming popular. However, the big size has two problems. One, expensive GPU usage cost. Two, too large for onboard processing. At Ninja Labo, we focus on compressing big AI models smaller to enable Edge AI, running directly on devices. Earth observation satellites are used for natural disaster monitoring, like wildfires. At stage 1, a satellite has limited computing resources, so the captured images has to send back to Earth and to be processed with big GPU in cloud data center. This takes really long time, causing slow responses. At stage 2, what we do at Ninja Labo, we compress big AI smaller so the satellite could process data directly in space without downloading data back to Earth. At stage 3, this quick response with small AI would avoid natural disaster damage. DNN model compression. The recent AI leap mainly comes from deep learning, so our focus is also deep neural network at our compression. Model compression has many techniques such as quantization, pruning, knowledge distillation, neural architecture search. The tricky part is to keep a good balance between size, speed, and accuracy at compression time. Also, how to combine those techniques efficiently at the same time is also another challenge. Here's one example of model compression for normal deep neural network. We compressed Resident 18 object detection model with ImageNet dataset. Additionally, we developed our own custom DNN runtime in C from scratch called Tiny Runtime without needing Python environment at all. The blue bar shows original Python environment. The orange bar shows Tiny Runtime. The green bar shows Tiny Runtime with quantization model. So keeping the accuracy as same as the original, but the execution time getting smaller and smaller, and maximum runtime memory usage drastically reduced, and model size is also reduced. While maintaining the original accuracy, we significantly reduced memory footprint. This is suitable for edge computing without GPU in cloud data center. Experimental setup. This time, we applied model compression for hyperspectral imaging, HSI. The process consists of four stages: one, dataset; two, model; three, compression; four, evaluation. For HSI dataset, we use high-spec net 11K dataset. For modeling, we use the pre-trained model SSCNet from high-spec-net 11K dataset. For compression, we apply only pruning using the model compression framework called Faster AI. At evaluation, we will compare the performance and memory reduction after compression. We will look into the detail of each stage. Dataset. One of the challenges is to find suitable HSI dataset. There are not so many available. As seen on the left, a lack of HSI dataset means a lack of pre-trained HSI models to compress. So we need a pre-trained DNN models. This time we picked up a high-spec net 11K dataset, a relatively new with pre-trained models. High-spec net 11K is satellite Earth capture images with over 200 spectral bands. Some bands may contain useless data as seen on the right bottom. For DNN model, high-spec-net 11K comes with pre-trained model called SSCNet, Spectral Signals Compressor Network. This model is designed for image data compression. It's same as autoencoder. SSCNet consists of two main components. One, encoder to compress the original image data. Two, decoder to restore the original image from compressed data. So at the autoencoder architecture, the bottleneck part is compressed data. The original size of SSCNet is nearly 700 megabyte. This is too large for onboard processing for most CubeSat. That's why compressing model makes sense. At model compression, we applied only pruning using the faster AI framework. There are numerous model compression techniques, but we didn't have enough time. Applying multiple compression techniques simultaneously remains a topic for future exploration. Faster AI is a clean architecture, making use of callback function inserted in normal DNA training and inference path. So we only need to specify such callback functions. Here are the results. The goal is to identify an optimal trade-off between computational resources and performance. On left top, memory size is reduced by 42%. On top right, VRAM usage reduced by 88%. And the lower part is the degradation of image data restoration. PSNR, peak signal to noise ratio. It's almost same as original point. And the spectral angle. This looks a bit different, but still it's less than 5 degree. It's quite acceptable for the indicator of this type of image compression. So while maintaining the original performance, these reductions makes the model suitable for resource constrained environment like satellites. Practical implications. Ninja Labo has a SaaS platform to compress DNN models. DNN model compression is not the main task of data scientists in most of the companies. If they provide us with DNN models, we will compress and return a compact model, and they can install for onboard processing. So user doesn't need any expertise in model compression, but we will do all for them. In the future, AI is expected to be used a lot more with diverse hardware environments. Data scientists, developers may create AI models only on their desktop environment, including cloud environment. Our SaaS, software as a service platform, would automatically convert such AI models suitable for any hardware environments. This approach is leading to AI marketplace, like the current mobile app store. So this is the future we are expecting. And our SaaS platform will play an important role in this picture. So Ninja Labo is a small startup looking for more piloting project to compress HSI DNN models. If you are looking for compact AI solutions, feel free to reach out to us. Thanks.